So once you get n equals 15.02, you plug it back into your equation and you get 45.17 is equal to 45.7. I guess that's all we have today for class. Tomorrow we're going to be learning about thermodynamics. Come to class prepared for that. I'll see you guys tomorrow. Hey, honey.
So, did you get paid today?
No, honey, I don't get paid till next week.
What do you mean you don't get paid until next week? Walter, we have bills due.
I'm trying my best, honey. I don't know.
That's not enough. We're $500 behind. The water bill's gonna get cut off tomorrow if we don't pay it. I have necessities. We have a baby on the way. This baby also needs necessities.
Honey,
and I can't work because...
Honey, can we please pull over? Please.
What's wrong? Walter? Are you okay? Oh my god. Walter! Honey, you have to help me get you up. Come on, we're taking you to the doctor. Come on.
Hey, Mr. Walter, I am Dr. Martinez. I am here back with your results. Can we please take a seat? Okay, so with your results, I am sorry to say that you have lung cancer. You have.
What does she mean? There's no way I have lung cancer. I have a baby on the way. I'm behind on bills. My wife can never find out. This would kill her. I must find another way to pay for this without her ever finding out.
Mr. Walter?
Mm-hmm. Yeah.
Are you paying attention, sir?
Yes, ma'am. Don't you have your own food?
This baby has a big appetite, Walter. Whatever. How was your doctor's appointment?
It went well. They said that pass out happened because of a lot of stress and the kids, yeah. What's that teach? Now they're still bad?
Nothing else?
No, nothing at all.
Okay. Oh my goodness. Do you remember my brother Frank?
The DEA agent?
Yeah. He just sent me a link. It's a crazy news story. It's like breaking all the TV sites. Look, they almost busted some of the meth cookers, some of the biggest meth cookers around town. Look, this is one of the possible suspects.
Do they have a name for this person?
Supposedly, well, they don't know the real name, but supposedly he goes by the name of La Garza.
La Garza? What does that mean? Doesn't that mean the crane or like
Something like that.
I wonder why. Maybe it's because of the long legs or like a long neck?
That's crazy, huh?
Or like a long nose?
Maybe.
That wasn't the best idea to lie to my wife, but when she showed me the picture, I realized that was one of my old students. And so today I will be going to find him and see if he can help me out. I know that this is probably not the best choice, but it is the only choice I have left.
Who is it?
Are you La Garza?
Depends on who's asking.
It's Mr. Walter from your high school chemistry class.
Mr. Walter? What do you need?
I'm in need of your help. I just found out that I have lung cancer and I have a child on the way and I'm behind on rent and I have no money and I realized that cooking meth is my only way to make money right now. And so knowing that you know how to do this and my skills in chemistry, then I feel like we could make a good team trying to do this and you're kind of my last hope.
I don't know. I mean, how good are you at cooking? Have you ever tried it before?
Voy morning class, they will be learning about thermodynamics. Thermodynamics is a branch of physical science that deals with the relationship of heat and different forms of energy. There are 3 different forms of energy that we really will be talking about in this class. These are potential energy, which is stored energy, or the energy of position. That's when an object isn't in motion, it's just standing still. Then we have kinetic energy whenever that object is in motion and it's moving through the air or rolling or any type of movement. And then you have thermal energy, which is heat, which is an outward manifestation of movement at the atomic level. Does anybody have a question?
What's kinetic energy? What does that have to do with this?
Kinetic energy is energy that something possesses by being in motion. You can actually find the energy, temperature, pressure, or volume by knowing certain heat formulas, which we have on the board. But I really won't be talking about them just yet. We're going to talk more in depth about them later on throughout the day. For now, the formulas that you know are Q equals MC delta T, Q equals M delta H FUS, Q equals M delta H VAP. And then, so each formula is the Q equals MC delta T, which contains the changes in temperature that find the specific heat. Then Q equals M delta H FUS uses change of fusion to find specific heat, and Q equals M delta H VAP uses change in vaporization to find specific heat. So each one's for different functions of fusion, vaporization, and the temperature. The term that belongs to finding the amount of heat is actually calorimetry. This question leads back to the phase change diagram, which will not explain. Did you get all that? I guess he doesn't care. Okay, well, we'll be next talking about phase change diagrams, specifically the phase change diagram of water. I hate my life. So first you have 3 different points: solid, liquids, and gas, which we know are the 3 different states of matter. And so this is just talking about how water changes through all of these, starting off as ice, which is solid. Then as the temperature raises, along with the pressure, this leads us to a liquid or gas, depending on how high the temperature will be. And then whenever you're at a triple point, and then you can also have a critical point. And that's about it, really, for thermodynamics for now. We're going on to our next slide, class, if you guys really care to pay attention. You have 2 processes, which are exothermic process, which is when energy is released as it proceeds and the surroundings become warmer. Then you have the endothermic, which is just the opposite, whenever the surroundings become colder. And we just talked about water phase change diagrams and phase change diagrams. That's really about it for thermodynamics. We'll go more in depth about them tomorrow. That's all. Can you turn it up there for a bit?
I'm storing up the heat.
Alright, we gotta get this boiling for it to start mixing properly. We're gonna add our color now in the store, remember? So we add a little bit of that to get the color to it. And then we get this, which is our chemical that creates our math. Just only a little bit, not too much.
And what's it called whenever the heat's being released?
That would be exothermic. Did you not pay attention to my class at all?
No.
So let me get that.
So what's endothermic?
Endothermic is whenever heat is being absorbed. And so then we let that, when we start boiling it, once it boils, this will become a vapor and it'll leave so that has a higher density at the bottom, which will be later used to create our meth.
And then we put a filter on it, and that's actual substance, so we use it in making the meth.
Yes. Alright, I'm just out of that boil for a bit for now.
Okay, let's turn up our boiler.
Alright, we need to let it cool down some more in the Tupperware so that way it'll create our crystal. Now that we got it at a good temperature, we just gotta pour it in here, and that's where our crystal meth will be coming from. Alright, let me just place it in here so that way it can cool down a little bit faster. Get our stuff ready. Gotta be careful, it's very important, very delicate. Alright, leave that in there for a couple hours and we should be good. So today we'll be learning about the law of conservation of energy. And so that involves sort of a system. A system is the part of the universe being studied at that time, and then everything else surrounding the system, and everything else that is surrounding the system. So the law of conservation of energy is the total energy of an isolated system remaining constant. And so that is important because that's going to be dealing with most of the formulas that you guys have learned so far, and we won't be learning today via Heo, Charles, and Grams. And so this is a heating curve chart, and so we'll be talking a little bit more about that today. And so, like many substances, this is mainly talking about water, and so this talks about the heat that is absorbed in every single different state of matter, so solid, liquid, and gas. And so the states of matter, like solid, liquid, and gas, are changed by boiling, melting, and freezing points. So we can see that melting's here, where melting starts from solid to liquid, and then we start turning into a gas. The formula PV equals nRT. Can anyone tell me how to solve this problem here? How about you, Paula? Never mind, none of you guys are really listening. It's okay. We'll just go into our Charles one. You guys don't care. Which is just the most simple one because it just combines everything with P1, B1, T2, P2, V2, and then T1, and then you just take out what you don't need, and then you can just solve like that. And so next up we have Graham's law, and so to solve that, you do this, but I would ask you guys to solve it, but you guys aren't paying attention. And so, alright, let's clap draw. Let's go out for your houses. I need my light. Alright, I think our math is finally done. Let's look what we came out with. It's not a bad one, I think. Let me pull out a piece here. Looks like it's 98% pure.
98% pure? How do you even get it that pure? I've tried multiple times, but I've never gotten it this pure.
Did you
before.
never pay attention in my class at all while I was teaching you? So, remember the equation that we used for converting gases to something else? So we had pressure, PV equals nRT, which P was our pressure, V was our volume, N was our moles, R was our rate, and T was our temperature. And then we just used the P2P that we stole, remember, along with the aluminum amalgam. And then, so we created a solution, which was then, this was our gas, remember when we were over there in the other spot?
Oh, so that's why you use the gas
And
law.
so, yeah, and then you use the gas law, and then that gets converted into this, and that gives us our pure substance that we have here, and our also deep blue color. Do you not remember?
No. But look, it's so pure.
We can't be here. I can't be seen. I got a family. I can't.
It's okay. It's
I
okay.
can't.
It's too late. We already made it. Do you know how much you can make off of this? I should try a bit first, though.